Greetings, programmers. Back we are again. Busted Thumbs here with Fluffy Wishes.
Hello!
And we are now working on our Frogger competition in our 8th episode. And again, we're back to the cars. This is where we left off last time. You can see we were working on our cars and we got 4 cars. In this case, the cars are looking like trucks because they're supposed to. We were working very hard on making sure we had the Y position set up correctly. And it came to be all this big long math here. And this big long math really came down to taking 180, which is the top of the screen, subtracting out our top margin, this little bit up here, and then subtracting out a bunch of rows. And the number of rows we subtracted out were the number of log rows, 1 row for the lily pads, 1 row for this purple bar, and then 1 row for each of the lanes depending on how many down it needed to go. That's what all of this stuff is here. And then we went a half lane more just so that we could center our car. So let's start working on X a little bit. When we start to work on X, we're going to have to deal with the fact that the center of the car is right there. So when we're positioning the car, it's being based on this particular center. So we can't just start the car on the edge of the screen or half the car will show up. We're going to have to move it off the screen a little bit based on its width. And in our last one, we had set the width to be based on the actual width of the size of the car, of the costume of the car. But when we set the size down here to the row height percentage, well, that means that that width is no longer correct. That its width is actually going to be a percentage of the actual width. So we really need to make an adjustment to the width. And the adjustment is the same percentage here that we're using here. So to do that math exactly the same, all we need to do is multiply by that percentage. And in order to turn row height into a percentage, all we need to do is divide the row height by 100. Well, it's 50 divided by 100.
50 divided by 100 is 0.5.
0.5, right? Which is half, which is what we want to do. So when we multiply by half, 50% is half. So what we want to do is make sure we get that right. So the row height divided by 100 is the actual width of the car when it shows up on the screen. Okay. So I'm going to make another variable for this sprite, which is its initial X position. And that's something we're going to have to figure out at the very beginning. Its initial X position is actually going to depend on its direction, and maybe we should just keep track of direction as well. Okay, so let's have another one that says direction. Remember, one of the things that it required in that competition was that every other row went in a different direction, left and right. Okay. So we can set. We're going to have to set both those things. Let's go ahead and set the direction and the initial X position. The direction is going to be interesting. We're going to use an if then else, and I'm going to use an operator you may not have seen before. I'm going to say that if this operator right here, if the lane number, where do we keep track of the lane? No, not the car lane, my actual
Lane number.
Lane number, yeah. So if my lane number mod 2 is equal to 0, then I want to set the direction to right. And otherwise, I want set my direction to left. Now what does mod mean?
Every other one.
It means remainder.
Oh.
When I divide, what is the remainder?
The remainder is the bit that you couldn't divide into any of the numbers.
So when I'm doing mod 2, what I'm saying is every other one is going to be a remainder of 0, and every other one is going to be a remainder of 1. So every other one is going to get right, and every other one is going to get left. And our initial X position is actually going to depend on these things too. So the initial X position for something moving to the right is going to be the left of the screen minus half its width. Okay, so we want the left of the screen, which is minus 240, minus half of its width. So that would be the width divided by 2. And we're going to do something quite similar here. Only this time we want to go to the right of the screen, and we actually want to add. So let's go ahead and get rid of that one because we're going to want to add. The initial X position is going to be 240 plus the width over 2. All right. So we've got a position, and we know where the car should be on the screen at its initial tick. But to know exactly where it needs to be, we're going to actually need to know what the position on the screen should be. We're going to need to know how many ticks over we're going to go. So basically, there's two things that could happen. We could be going left or we could be going right, and the math's going to be just slightly different for each. So let's go ahead and just leave that there. But now let's go ahead and use an if then else again. And I don't have to do this lane number mod. I could do this lane number mod too again, but I'm actually keeping track of that now. So I can go ahead and say if my direction is right. Where are you, direction?
Right there.
There you are. And you're showing up. We don't need you to show up. If my direction is right, then I'm going to go right, and if my direction is left, I'm going to go left. And the reason why I'm doing this instead of doing that mod again is that what if later on I want to have two rows that both go right in the same direction? I can change that up here, but everywhere else I'll be working with the direction variable, so I don't have to change it in a lot of places. Okay, so if we're going right, then we actually want to take our initial X position, and right is adding pixels when we go to the right in X. So we're going to have an add. We're going to start with our initial X position. Initial X position, initial X position. Yep. It's almost like they're alphabetical and I can't find them. It's pretty crazy, huh?
Yep.
Yeah. Alright, so it's initial X position, and then we're going to add to that the velocity times the number of ticks that we've gone so far. Okay, so the velocity is something we're keeping track of, and the number of ticks that's happened so far is going to be the current tick minus its initial tick. So tick, 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 tick minus its not initial entry tick, right there. And that should be where it should be on the screen if it's traveling to the right. We're going to do something similar with setting the X if it's traveling to the left. Only this time we're going to subtract. So we again need the initial X position. And we're subtracting the exact same thing here. Where are you? They're over there. Okay. And that's where it should be on the screen at the tick time. And then it will make it interesting if we make sure every time there's a tick that it positions that car once again. One thing we also didn't do, we didn't set the costume based on the lane number.
We need to do that.
Did we?
Nope.
No, we didn't. And we should have. So let's make sure we do that. I'll go ahead and do it here. Set costume. We can put that over here. Let's go ahead and move that down there. Get that out of the way. It's kind of taking up a lot of space left to right, so we can put it all the way over. The costume logic should be fairly easy. It's all based on our lane number. And actually, I'll just use 4 of these. I don't care if we have to evaluate all of them. I'm only doing it once when everything's created. And I'm going to say equals, 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 equals. And now I'm going to do something a little funny. I'm going to throw mods in all of these. And I'm going to put the lane number into each one. Lane number. And I'm going to use 4. We have 4 different costumes for our car. And if I do it this way, then I'm going to catch every case. If I make this 0, 1, 2, and 3.
There's space in the 2.
So with numbers it shouldn't matter, but I will fix that. There we go. No space. Thank you, though. And we're going to set the looks so that we switch the costume to each one of those. Now, what did we say for lane 0?
Lane 0 was red.
Okay, which is what we have. What did we say for lane 1?
Blue.
Blue. For lane 2?
Orange.
Orange. And for lane 4, truck. One more thing we need to do.
What?
The cars are facing in different directions when they're traveling right or left, but all of ours are facing to the right in our costumes. So we should flip those around, shouldn't we?
We'll have some backwards drivers there.
Yes. So what we want to do is say if the direction, which we've already set, if the direction is equal to left, then we need to flip it all the way about. And that's actually in motion. We're going to need to point in the direction, the opposite direction. Up, left, like that. In this case, we're doing things the scratch way, and 90 degrees is to the right and negative 90 is to the left. So our drop-down menu is correct. Ooh, what's going to happen when we click play? We've done a lot of changes. Who knows what's going to happen?
Hopefully it'll work.
Hopefully it'll work. Well, look at that. That's pretty interesting.
They look like caterpillars.
You know what I think? We're creating an awful lot of cars. Far too many cars.
Scratch gets upset when we have that many cars.
Scratch does have a limit. When you get up to 300, I think, 300 sprites, it will stop working.
Yeah.
So, but the good thing was our cars were moving. They were moving left and right, and they had the right costumes, and they were in about the right spot. But let's see what was going on to make us create those so many times. Oh, right. So, on every tick, we were coming in here, and if the last car tick was 0, then we were creating a car, but we were never changing the last car tick again. So let's fix that. I'm going to actually make this less than 0. And let me make sure that I actually put the last car tick as less than 0 as well, which we did over here. So when we get started, I'm going to say -1 means we've never, ever, ever had a car. -1. Like that. And then I will make sure that when we create that car, that we update, replace the item of index of last car tick with tick. Should we try again?
Mm-hmm.
Look at that.
It works.
Look at that. It's not even all that unreasonable. In terms of the speed and everything. Isn't that cool?
Uh-huh.
Unfortunately, watch this. I can jump right into the car.
Oh.
We'll have to deal with that in a little bit. But we've got cars that are going across the screen. One thing we do need to do is to make sure that the cars go away and that we get more of them. But this is pretty good.
The red one stopped too early.
Well, no, it stopped because
Oh,
our
oh.
time went to 0. And what happens when our time goes to 0?
Everything stops.
The game loop stops.
Yes.
And it was always updating based on the tick.
Yes.
So that's why it went to 0.
Okay.
And you can see here that Scratch actually doesn't allow us to go all the way off. So we'll have to just deal with the way Scratch lets us deal with cars. And just make it disappear later. Okay, so in our next one, we now have cars. They're the right cars. They're moving in the right direction. They're moving at a certain speed, which we've told it to move at. There's only one of them in each lane. But that's okay. We can fix that in the upcoming thing. In the upcoming versions, we can play around with the velocities and everything. But we've got cars that work.
Yay!
And do they look like good cars? What do you think? I think
Yes.
they look like good cars. All right, progress. I told you we'd do cars. It took us about 3 episodes to get the cars in there. They're done enough that they look like they're done, even though they don't quite function all the way. So I'm pleased with the progress that we've made. I hope you are too. If you're following along, it's starting to look kind of fun, huh? We can see how we can work with all these things and make ourselves a game here. All right, cars done. Not really. Cars working. I hope you've had fun watching this one. We'll do some more with this in the next time. I hope you're having fun making one along with us. We'll see you later. Bye-bye.